The synthetic cheat sheet talked a lot about moving functionality from one atom to another, and that's what I want to focus on in this page. I just want to focus on some practice problems of figuring out which direction to go and how to move these things in real life, okay? So this chart is the same exact one from the cheat sheet, but let's go ahead and fill it in really quick. So remember that, let's do our eliminations first. What kind of base would be favored for Zaitsev elimination? Small and strong. Okay? And then for a Hoffman, it would be bulky. Remember that? Okay? Then for the Markovnikov alcohol, Markovnikov alkyl halide, the alkyl halide was easy. That would just be HX. Okay? For Markovnikov alcohol, the one that we usually use is just HA over H2O. Okay? But we can also use oxymerc. I'm just going to write it down. Okay, we can also use oxymerc if we want to. Okay? Then for the anti-marks, it was the same deal, but I have to use HBr specifically over peroxides. Okay? And for my alcohol, for my anti-mark alcohol, I would want to use hydroboration. Okay? I'm just going to write hydroboration here, because you guys are such pros at hydroboration already. I'm just going to write here BH3. Cool. So now we know kind of our roadmap, and then remember we said that if you start off with a alcohol, you need to do an elimination first. If you start off with a double bond, you need to do an addition first, because it doesn't make sense. You can't add to something that's already added. You can't eliminate something that's already eliminated, so you have to alternate. Okay? So that's what this just says up here. So what I want you guys to do for these practice problems is, first of all, the most important thing, honestly, is just identifying which direction do we want to go in, because that's something that a lot of students aren't used to doing, and that's not something that professors really teach. So for problem A, go ahead and pause the video and just tell me, like, is this going to want to go in a more substituted direction or in a less substituted direction from that chlorine to that alcohol, okay? So literally pause the video, and then when you're done, tell me if it's going to be in the more substituted or less. All right, so I hope that you said that it's going in the more substituted direction. Okay? Why? Because notice that I'm starting off with a primary and I'm ending up with a tertiary. That's all you need to do. That means I'm going in the more substituted direction. Okay? So for B, what direction am I going? Well, it's the opposite, right? So I'm going from tertiary to primary, so this would be in the less substituted direction. Does this give us a clue about what reagents we should be using here? Yeah, it does, because it's like we have our whole blueprint right here. First of all, I know that I'm going in for this red one, A. I know I should be going in the more substituted direction, so I know I should be using the reagents from the top of my chart. I should be using either my Zaitsev elimination or my Markovnikov additions. Cool so far? On top of that, I'm starting off with an alcohol. So since I'm starting off with an alcohol, which one should I start with, addition or elimination? I should start off with elimination, so check that out. It's telling me exactly what to do. I should use a small, strong base to do a Zaitsev elimination for my first step. Isn't that crazy? Because that's going to lead me to the more stable product, to the one that's more substituted. Isn't that crazy? So I just want to show you guys how it's like a roadmap. Like, this is such an awesome chart. Let's keep going. So why don't we do the first one together, since, you know, this is just really good practice, and I think it helps if you guys are listening to the way that I think about it, okay? So we just said that for my first step, I should use a small, strong base. That's a Zaitsev base. So let's go ahead and, in this case, I actually don't have the choice between Zaitsev and Hoffman. Notice that I only have one elimination product possible, and that's this double bond right there. So I should just do whatever is going to give me the highest, the most amount of elimination product, not the most Zaitsev, okay? So what that means is that I should actually use a bulky base, because my small bases might do an SN2, okay? For example, oxides. Oxides will do an SN2 if it's primary. So let's actually just use LDA. for my first step. Okay? So what that's going to do is that's going to give me a molecule that looks like this. Okay? So now I have that. So now, am I still trying to go in the more substituted direction? Yeah, I'm still trying to go towards that tertiary. So I should still be looking at the top of my chart. Okay? I should be looking at the more substituted direction right now. Okay, let me make it in red. Okay, so I should be going in the more substituted. And since I'm starting with a double bond now, should I use addition or elimination? I should use addition, okay? So it's really up to you guys which one you want to choose, okay? But I would prefer to pick, unless you can't have carbocation shifts at all, which happens sometimes, let's just pick HX, okay? Because HX actually can shift, and it's easy to eliminate, okay? So let's go ahead and just use HBr, okay? Now, if you couldn't shift at all, then you should use, instead of HX, you should use oxymerc. Oxymerc is the one that you choose when you can't shift at all. So what that's going to give me now is it's going to give me a carbocation here that's then going to shift through a hydride shift to here. So what I'm going to get at the end of this step is I'm going to wind up getting a Br right there. Okay? Cool. So now I've got a Br, okay? And I'm trying to figure out how to make that into this, okay? Do I have a one-step way to do that? Do I have a one-step way to take that Br and make it into an OH? Well, maybe what you're thinking is SN2, okay? Remember that SN2 reactions could swap out an alkyl halide and put something else there? But actually, that's not a great strategy. And the reason is because SN2 can't work on a tertiary, okay? So really, the best thing to do here is actually just let's eliminate, and then let's add the alcohol, okay? So let's go ahead and do that. So what we would do is we could do any elimination we want because we're just trying to get that Markovnikov site. So we could just use any Markovnikov base like NaOH for tertiary. And what that's going to give me is a double bond that looks like this. Okay? So now I have a double bond that looks like that. And then I could use an acid catalyzed hydration to do my last step. So I could use basically H2SO4 over H2O, and that would give me my last step, a Markovnikov alcohol, right in the middle. Okay? So that was one way to do it. Notice that the amount of reagents that I used was LDA, HBr, NaOH, and then H2SO4 over H2O. Not terrible. We did it in 4. Okay? I'm going to write that down just so you guys have it. We had HBr, then we had NaOH, and then finally we had H2SO4 over H2O. Okay? So that was a decent synthesis. Was there a faster way to do it? Actually, there was. There was a faster way to do this, and I wanted to see if you guys would see it or not. Okay? A faster way to do this would have been, and both are right, one of them is better though, would have been, yeah, I'll do LDA from the very beginning, okay? And that would still give me this double bond here, okay? But then instead of doing HBr, at the end what I wanted was an alcohol anyway. So how about instead of doing HBr, I just did my acid catalyzed hydration. So I did H2SO4 and water, okay? And what you'll notice is that, well, that gives you, what does that give you? Well, that's going to give you a carbocation here, and that's going to shift because of a hydride to here. So I'm going to wind up getting a carbocation here, and then that's when my water attacks. So actually, my water could have just gotten there in 2 steps, okay? I could have just used LDA and then H2SO4 over H2O. Okay? So both of them worked, and that's the thing about retrosynthesis. A lot of times you're going to have several options available to you to get something done. Okay? The better one is going to be the one that happens in the less steps. So the one that we should really pick is this one. That's the better one. Okay? Cool. So I hope that you guys just saw how we can use this flowchart, basically, not this flowchart, but this like kind of like this guide to figure out, are we going more substituted or less substituted, and then what's kind of our goal. Okay? So now we're going to go to B, and I want you guys to do this one all on your own and figure out how to go from the more substituted to the less substituted. So maybe you should be looking at the other part of the guide, and I'm going to let you guys try to take care of it, and then I'll answer it for you. So go for it.